Hello everyone. So welcome to second stream. This is mainly chess stream, but uh, we are also going to discuss about the PCB design or electronics or RF engineering or whatever questions you have. You can just put it in the comment section, and yeah, I'll take those questions. Uh, yeah, and parallelly we'll be playing couple of chess games, mainly rapid, 10 minutes. So if you are interested in playing game, either you can drop your chess.com ID in the chat, or you can just directly create a challenge on me using, yeah, you can just follow my, you can see my cursor here. You can just copy paste this steam PCB underscore chess on the search bar somewhere on chess.com, and there you will find it. And then by creating a challenge, we can play chess game. All right, so yeah, we can start with our first game. And in terms of topic, so I've prepared a couple of topics. Let's say we are going to talk about power supply rejection ratio and PDN crosstalk. So in the previous team, I've talked that I'm going to take a couple of webinars from Rod and Shores. So yeah, it was not a lot. It was just 45-minute webinar, but there they've discussed a quite advanced PDN crosstalk analysis and its measurement. So yeah, it's a bit it's a bit advanced topic. We're not going to sort of no, we can able to see these issues in our regular designs as well, but not that much. So it will be sort of negligible. But yeah, we are going to talk about a bit like whatever I've learned there. I'm just going to discuss all the points and my notes from that. So yeah, these two topics I've prepared, and yeah, in case of any question, you can directly ask me in the chat. So let's start with our very first game. So as you can see, currently my rating is 1186. Yeah, I'm a bit nervous playing at this rating because this is my sort of highest rating here. Yeah, so I got my first message in the chat from Bhuvan. What do you do professionally currently? So I'm electronics hardware designer. Yeah, so that's what I'm doing from last 6 years. So in case you don't know, hardware designers are like, yeah. So in my case, electronics hardware designer is basically PCB design, motherboard design, and yeah, mainly you can say PCB design, right? So yeah, we'll just design the circuit, run simulations, and yeah, these sort of stuff. player is so strong. Oh my God. I knew it is coming. All right. So one game lost. Uh, okay. So now I can just switch to our first topic. Whatever you want to discuss first. We can start with the workshop, which I took on PDN crosstalk analysis and its measurement. And then yeah, then we'll play one more game, and then after that, one game we'll talk about PSRR. All right, so I'm just switching to chatting scene and setting up my note. So let me know if you can see that. One sec. So I have to change my to Google Meet. Okay. Yeah. Now you can able to see. All right. So let me know if you can able to read it. So these are just note mainly related to PDN crosstalk. Uh, so we can start with first we'll understand what is PDN crosstalk. So as its name suggests, PDN means power distribution network, and crosstalk means there is some aggression net and victim net, right? So there is some electromagnetic coupling is happening between aggressor and victim. But here net means yes, thanks Bhuvan, thanks for confirming. So yeah, here net means power delivery networks. All right. So let's say we have two power plane sections or something, right? In a printed circuit board, and there is some electromagnetic coupling is happening due to the switching on those power delivery networks, right? So that we call PDN crosstalk. Yes, I can turn off the music. Thanks. Yeah, now it would be turned off, right? Can you confirm, please? Yes. So yeah, so that is what we call PDN crosstalk, right? Now, so from that workshop, I mean, we already know that there is this due to ground loop or due to ringing on ground or power planes, this can happen, right? Now, now the important thing was this PDN crosstalk was causing jitter on digital signals, right? So that was one thing, sort of important point if you can see somewhere here. So yeah, that was something very interesting. So uh, if you have issues with power integrity in your ground and power planes, then your signal integrity will also compromise. That was very interesting topic in that workshop. So I'll also put that link in the description. It's on demand webinar. So you can just go to the Rod and Short's website and register. Just put your mail ID and fill the form. And you can just watch that 30-45 minute seminar. It was really interesting. They'll also share the presentation and everything with you. So you can just sort of keep it, in your a local system, and you can recall it whenever you want. Obviously, it was sort of marketing seminar, so there they were talking about mainly yeah, how you can how you can measure the PDN crosstalk using their instruments, right? But the topic itself was very interesting. Okay, so we have discussed already till here. It's a power integrity issue was there due to, yeah, so due to ground and VCC bounds, right? And we are already aware of this signal integrity issue. Uh, so they've also talked about a couple of examples, and they were showing the proper setup where they were probing some ASIC boards, right? And there the aggressor current was going up to 100 amps. All right. So this is, I'm talking about the switching power supply. The current was going up to 100 amps, which is, we know that it happens in case of a ASIC, right? So that was aggressor. And on aggressor, the peak to peak noise was around 93 millivolt, right? So you can imagine the design was so much efficient. Even if we'll just use a 3 amp DC-DC converter and we'll just measure the just put the oscilloscope into AC mode and measure the ripples, you can see it can exceed that limit, right? So imagine the efficiency of that design which they were presenting in their presentation. So yeah, it was just 93 millivolt uh, peak to peak noise was there uh, at 100 amps of current, right? And there was another victim net. So here a victim net means victim PDN network, all right? So there was another nearby power plane. Uh, yeah, so that was just at 15 amp. So you can compare, like it was pretty much silent. It was at just 15 amps compared to 100 amps of PDN network. Now, due to this crosstalk, as soon as we were putting or increasing the current at aggressor net, the ripple on victim net was going up to 190 millivolt, right? So now you can able to see the effect of crosstalk between the aggressor and victim net, right? So yeah, this if this is happening in your design, it can also cause the signal integrity issues. So that was the entire idea of their presentation. They just wanted to demonstrate this. And they've also given some rule of thumb. So one was from the presentation that they've concluded the crosstalk between PDN can cause up to 10 to 30 dB noise increment from 100 kilohertz to 50 megahertz due to PDN crosstalk. All right, so this it can go up to, so yeah, so it can go up to uh, 10 to 30 dB more if there is a crosstalk happening between the PDN, right? So ripples can go to this much more intensity, right? Uh, they've also shown the effect of ground loop in this PDN crosstalk. So in case if there is no ground loop, all right, then your crosstalk will be pretty much this much. Sorry, this much, right? If there is no ground loop, right? But if there is ground loop, then we'll have further 10 to 30 dB of ripples, right? So that was another very interesting findings they had from their measurement. Apart from that, they've also talked about how you can measure that and do the analysis and how you can find these things. So there they've mentioned two types of measurements we can perform to identify the power integrity. One was, I mean, I don't know if they have named it or it is a general term, but one was small signal testing, and other was large signal testing. Right. So under small signal testing, uh, we can do PDN impedance measurements of power planes, PSRR, of DC supplies or LDOs, right? And frequency response. So these are all the measurements we can do uh, on power planes and see if it is within the limit or we are getting something crazy is happening on these parameters or on these measurements, right? Apart from that, they are also suggesting another type of measurements which we can perform to sort of optimize the PDN crosstalk. Another was transient response, step response of the supply current, and voltage droop. So this was I didn't know that about this term voltage droop. So voltage droop is let's say we are probing our DC-DC converter, let's say buck converter, and suddenly we have just increased the current of buck converter, let's say from 0 amps to 5 amps, right? Just put some electronic load and just turn on the electronic load as 5 amps. Now, due to sudden increase in current, we'll see some crazy ringing at the voltage side. So we call it voltage droop. When are you going to finish the rest of your Udemy courses? Yeah, I'm working on it. I'm working on it. In previous stream, I've also talked about there are two more courses I'm putting on Udemy for free. Uh, yeah, so one will be on OrCADX. Uh, there I'll discuss all the AI features which we can use in our day-to-day PCB design. Uh, yeah, and another course was rigid flex PCB design. So yeah, this is what I'm planning in upcoming days. So yeah, but slowly I'm sort of yeah uh, putting more content on channel, and because my YouTube channel was also dead for almost a year. So yeah, these are all the things which we got to know in just 45 minutes. It was really effective training or seminar or webinar, you can say. Uh, yeah. So next we'll talk about how to do PSRR measurement for an LDO, and that will talk after playing one more game. So let's go back to chess.com. If you want to play a couple of games, you can just, yeah, drop me your ID. So I'll send you the request here. So I'm just going to gameplay again. All right, ready to lose another one. Okay, I'm clicking on another new 10-minute. Okay, another strong opponent. Let's see how it goes. So let me know in the comment section if you have any question related to PD and crosstalk. So yeah, I was pretty much familiar with all the measurements they have suggested in at the last of presentation, uh, small and large signal measurements. So yeah, it was quite good. I guess here I made the mistake. That person can pin the knight. Oh, he missed it. I'll go back. So here I'm sort of protecting this particular block. So I can't put his bishop at this position to pin it. Okay, let's go ahead with knight development, and then we'll just start moving these pawns. Okay, so here the idea is just trying to pin this knight. And again, I have this bishop protection, so it will help. Let me know in the comment section if any of you are following this World Chess Championship 2024. It's happening between Ding and Gukesh. So yeah, it's pretty much interesting. So in yesterday's game, Gukesh was ahead, and then if I put my here, this, this, yeah, I lose one pawn. What I can do here is so now this bishop is sort of under attack. So he can simply take it. I have to take it because that will be check, and I can just put my knight at this position. Okay, so here at this position, I'm attacking. Okay, I won one piece. Looks like I won it. Yeah. Mm, okay, this knight is also pinned. Oh shit. Come on, man. And I've sacrificed my knight. Oh shit. I don't know how I can do this. Hmm. If I do this, will be check. Then I'll cover it here. Oh shit, I lost one piece. Okay, I'll take this. Okay, he blundered. Okay, yeah, this was good game. Uh, the opponent was playing good at the very beginning, and yeah, all right. Yeah, yeah, I know I got your point. So the plan was for this advanced course. Yeah, I mean, if you didn't like it, you can simply apply for refund from Udemy. Uh, but yeah, plan was to create three courses out of it, and yeah, it's a bit time taking, man, and it's not that easy. Plus, yeah. So it was one FPGA kit I wanted to design from Microchip. But yeah, it was. I mean, I've planned the entire course and everything, and then Microchip was not ready to ship that particular development kit. Uh, so yeah, there that code was stuck. Uh, yeah, yeah. I mean, I've planned if I can show you my instructor page on Udemy. I've planned like 6, 7 courses on that. Uh, yeah, like on signal integrity, there was one on uh, thermal analysis, uh, thermal and PDN analysis using cadence tools. Uh, yeah, one was using the topology explorer and security aurora signal integrity analysis. So yeah, I mean, my plan was to create all these courses, and then I was just so busy with uh, yeah, work, and obviously to teach you really good stuff, I've to also spend a lot of time learning, right? So yeah, let's see. I'll start uh, completing those course, and yeah. All right. So next, I'm just going to talk about PSRR measurement. Uh, so I'm just going to present uh, this PDF from Texas Instruments. So it's really nice PDF I found online. And one sec, let me share my screen. All right. I hope it is readable. Uh, I can zoom in a bit, but then it will be out of frame. Okay. I mean, you can also download that using the link given in the description. I'll just put it there if it is not already. Okay. So the main part is so I guess you guys have already gone through with this term PSRR. So whenever you're planning to select some LDOs, a linear voltage output. Uh, so for LDOs, this is one parameter which we all always look for, this PSRR. And as its name suggests, this is power supply rejection ratio, right? So it's a ratio of input ripple and output ripple. So whatever ripple you are inserting into the LDO, uh, and whatever the ripple you are getting at the output side, right? It is that ratio, right? Uh, So yeah, we just sort of need this parameter from the LDO's data sheet, and there they basically give you a plot of PSRR versus frequency, right? So yeah, so this value can vary between few dBs to 40, 50 dBs if you go for really low noise uh, LDOs, all right? So here they've given the formula. If you want to calculate it, you can simply, if you already bought the LDO and they didn't give you this parameter, you can just measure that, right? You can just connect the probes on input and output in AC mode, and yeah, measure the peak to peak ripple, put the values here, and you'll get the decibel value, and that will be your PSRR. They've also given some plots here. So, okay, why it is so important? So here they've also mentioned the purpose of using it. So it can be there can be these noises of 50, 60 hertz supplies or the switching ripples from the DC-DC converters, right? So when we are using LDOs in very sort of low noise environment, it can be, let's say, you're designing some clock network, and there you need a really good low noise power supply for that clock generator or RF synthesizers uh, or some clock fan out chips or whatever, right? So there you need really low noise power supply. So the internal PLLs will work efficiently, right? So there you need to just take care of that whatever supply you are connecting to those chips should have uh, low noise, right? Or shouldn't have these frequency noise, either the AC supply noise or if you are using DC-DC converters, it also has some switching noise, right? So yeah, so to improve that thing, we just don't uh, we avoid connecting DC-DC converters directly to these sensitive chips, right? So there we use DC-DC converters and then we use these low noise LDOs and then we connect that supply to PLLs or RF synthesizers. So yeah, that's a sort of architecture we follow for low noise environment. And yeah, so that is why these parameters are really important for LDOs. So here, as you can see in this graph, uh, so here we have the frequency, here we have the uh, PSRR in dB. So as you are increasing the frequency, as you can see, the value of PSRR is going low. It's going low, which means the ripple input is high and ripple output is low, right? So this is sort of good thing. And if you scroll down, here they've also mentioned some examples like how you can do that and how you can measure the PSRR of your LDO device, right? So here you can see this is the example, and there they are. So these are the probes they are connecting to get the ripple voltages, and based on that you can calculate it. So it's like step-by-step process. Really useful PDF here. Here they are giving another example like measuring the PSRR using oscilloscope. So you can also follow that. I'll attach this PDF in the, yeah, it's the same similar thing. So here they are just measuring the ripple of blue line is input, red line is output. So here you can see, if I just zoom in a bit, ripple input is this, ripple output is 194, and they're just putting it in this formula, 20 log ripple input upon ripple output. And if you calculate it, it is 14.16 dB. Uh, yeah, that's sort of pretty much. So you can just go through with this PDF. It's like really uh, to the point explanation of this particular parameter. All right. So it's really useful if you're designing really low noise schematic. So yeah, there's a couple of things I've planned. We can go back to our gameplay scene, and I'll just play one more game, and we'll be done for the day. All right. So I'm getting some question. What's the best way to be connected with you? I think you're not very active on Instagram or YouTube. Yeah, yeah, man. I mean, I'm trying to do that. That's why we started this sort of live session, so we can just discuss some topics. Uh, and you can also suggest a couple of things. So yeah, I'm not sort of expert or anything, right? I'm like you guys, still still learning a lot of things. So these days I'm sort of reading about RF designs and RF simulations. Uh, so yeah, I'm also learning simulations using Keysight ADS. Uh, yeah. So I can give you one scenario. So let's say uh, you have, yeah, you have to just design a, let's say, 10 or 20 gigahertz transmission line. But because of limitations, you can't just keep routing that line on one layer, right? So you have to go through with one via, right? So just imagine how you're going to design that 10 or 20 gigahertz via uh, for a transmission line or for that transition. Let's say from top layer to bottom layer. You have one component sitting on top layer, one component sitting on bottom layer, right? So it's not that you can design any uh, like that 50 ohm via using a Saturn PCB toolkit, right? It will not work for that frequency. Uh, so yeah, there you have to sort of run the sweep analysis and sort of EM simulation uh, for VIA. So the ADS, they have really nice VIA designer tool. So using that, you can just fill or you'll stack up, define the transmission line width and everything. Uh, and yeah, there you can just put all the parameters of via, and you can also do stitching using that tool. So stitching is like you stitch uh, ground vias around that signal via, so that those ground vias will act as a return path for signal via. So yeah, it's really interesting to design. And yeah, when I got to know about it uh, last year, I was like, because I didn't know about this tool before. Uh, yeah, so I was like, I don't know how we can do that. And I was generally applying the Eric Bogatin's rule of thumb to do all these calculations. And you can also model VR using Hyperlink Linux tool, right? They have this uh, circuit simulation there. You can just, yeah, sort of thing. You can just sort of define all the things. Similarly, you can do for differential or single-ended. So yeah, but it is just one scenario. Similarly, let's say you have to route really high frequency component, really high frequency transmission line through rigid flex, right? So you can't just route it like that by calculating the 50 ohm on Altium Designer and just follow that width. Uh, so yeah, it's very interesting to learn about these things, and I want to share it with you guys. Yeah, through discussions, or I can also prepare some simulations next time, so I can show you while playing chess. Uh, yeah, so let's play one more game and then we'll see. Okay, so this is quite strong. I don't know. I guess today chess.com wants me to just lose all the games, but let's see. So the player is 1219. He must have been played a lot of games before. Okay, I'll go with this simple Italian. Okay, I'll attack on this. I'll take it. I should take it here or here. That I need to decide. Oh, okay. That was strange. Hmm. Next, I'll move this pawn. Okay, I'll just take it. Hmm. So here, check is coming to be a bit careful about it. Now, how I can block it with this. Hmm. Person is playing too good. What's the next move? I guess I have to lose this bishop. There's no other way. I'll be a bit greedy. Just checkmate is coming. Okay, it's not check. No, it's checkmate. Yeah, checkmate. Checkmate. Check. I'll, mm, hmm. Man, it was complicated, man. It was complicated. I'm still beginner. Okay, don't expect too much from me. I got the text from opponent. He was saying, uh, "I'll checkmate you if you don't resign." and I need this confidence in my life. Uh, but yeah, like there are like tons of strong players, and they're playing from ages. Uh, so yeah, I guess that's pretty much for the day. In the next week, live, I'll come up with definitely come up with some good simulations. All right. So I'll teach you how you can use it in your day-to-day life to optimize your PCB, and I'll also come up with some list of seminars and webinars happening around the world. This time also I prepared the list, but next week there's not much free seminars happening. Most of them are paid, and yeah, they are offline. Uh, but yeah, next week uh, there are a couple of webinars which you guys can attend, and yeah, mostly signal integrity related. So it would be fun for you. So yeah, that's pretty much for the day. See you in the next stream.